All right, integrated 3 students. This is the final lesson. This one is sort of last minute. It's gonna be short, but it's kind of last minute. You're taking your test tomorrow. You're supposed to take your test tomorrow, and I have this one last topic because there is going to be one question that will be similar to what we're going to see on here. Now, there's no Delta Math practice for these problems, so we're just going to put these in our notes, and hopefully it sticks. It's not overly complicated, but let's go ahead and get into it. Okay, so let's go ahead in our notes, draw a line. Let's title it Logarithmic Equations, and we're going to say logs on both sides. All right, and you can see exactly what I'm talking about with what I have set up here. So I'm going to pause and let you go ahead and make sure you get this written. All right, so here we have a situation where we have logarithms on both sides. Now, what we've normally been doing with these is we've been converting them back to exponentials. Let me show an example. So here's the Delta Math part of this, and on Delta Math, oh, one second. On Delta Math, we would convert this to solve this. We would turn it into an exponential. Base 2 of 5 equals x. And we would be able to solve this with no problem because of using that conversion. Now, whenever you have two logs on both sides, we're not actually allowed to do any of that stuff, okay? We have to have another way to do it. And we'll talk about how it's actually a pretty simple approach that we're gonna be doing, okay? And don't write this, but you can almost imagine like what we did with the common bases. If this was 7 to the 2x minus 4 equals 7 to the 5x minus 1, I would hope that you would know what to do on this, because that is very similar to what we did with the common bases. These types of questions here where we had to get a common base, and then once we got the common base, we'd simplify the exponents and then drop those bases and solve the set the exponents equal. So we would know how to solve this here. I would just set the exponents equal, right? So this is an analogy to help you compare these, okay? But we're not going to be doing it that way. Or that actually isn't, or we are going to be using that method, but we have to look at this a little bit differently. In order for us to solve this, we have to make this inside the parentheses equal this right here. So all I'm going to do is take what's in the parentheses and set it equal. It's actually a pretty straightforward approach to solving this. Okay. Now that we have it set up like this, this is a problem that is from, freshman year, even middle school, using 2 steps to get x by itself. So I would first subtract 2x. Goes away, so I get negative 4 equals, this is going to be 3x minus 1. Then we add 1 to both sides. I mean, we all know where this is going, so this is going to end up giving us, and I'll write it over here to the right, so it's going to give us negative 3 equals 3x. We divide 3 from both sides. It goes away. We get x, and this is negative 1 right here. And you can't see because my camera's in the way, but there's the solution right here. So negative 1 is the answer to this. Now, there's a problem, okay? We need to actually check this. The reason that we need to check this is just like what we had in a couple units ago with the radicals and the rationals. We can end up with solutions that are not valid, and we had a special name for those. They're called extraneous solutions. So let's go over to a calculator, and we are going to put in negative 1 into where the x's are, okay? So on my calculator, I'm gonna go to my other display here. Let me pull up a calculator. I'm gonna do log. We're gonna do base 7 of, we want 2 times -1 minus 4. Okay? Let's look at what happens. Okay, it says not a real calculation. Not a real calculation. Let's think about why that is. Well, if I go, let me go back to my main display here. What happens when I plug in a -1 in here? Well, that makes this left one log base 7 of, this is, when I plug in a -1, that makes this -2 minus 4, so this is minus 6. And we'll notice on the other side that if we do log base 7, we plug in a -1, we also get -6. And we assume, now that they look the same on both sides, that they're going to be equal, right? But as soon as we plug in either of these, going back over here, it's going to be a non-real calculation. So let's explain why that's happening, okay? If I go back over to this logarithm, if we change this into an exponential, we're trying to show what value makes this true, right? The base would be 7. Trying to figure out what the power is that I would raise 7 to get -6. Think about it. Is there a power that exists that I can take 7 and I can raise it to get a negative? Well, if I do 7 to the, let's even do a half power. No, it gets smaller, right? Or if I do a negative power, negative, let's say 2, that's 1/49th. That's a, if I turn that into a decimal, it's just, we aren't going to get there. The numbers are only ever going to get smaller, but they're never going to actually become negative. It's not possible, okay? It is not possible to raise something to a power here and get a negative number. So that's the biggest thing. So when we look at this right here, this -1 equals x, that's not true. There is no solution to this problem. We'll write that. And then this ends up being what we call extraneous. Fit this in here. Okay, extraneous. That doesn't look great, but spell it the best you can. It's not, this isn't English class, you're fine. So this is an extraneous solution. Okay, so we have that in the back of our minds now. We know we have to check when we get these solutions, but at least you have the process down of what's inside of the parentheses needs to be set equal. So, example 2, I'll pause and give you a moment to not only write this down, let me move my camera back down, not only write this down, but also try to solve it. And you can, by the way, treat this 13 like it's in a parentheses. So I'm going to pause and let you try to not only write, you need to write it down, but also solve it. This is example 2. All right, so hopefully you had a chance to try to solve this, and hopefully you remembered to check it to see if it was extraneous. But we get -x minus 2 equals 13. And this is a very sort of straightforward solving equation. There's not even a variable on the right side, so we're going to add 2 plus 2. We get -x equals 15. Then we're going to either, you choose divide by negative or -1 or multiply by -1. I always like dividing by -1 when I see a negative because it's multiplication, so that goes away. We get x equals -15. All right, now when we check that to make sure that it works, we'll go to our calculator. So I'm going to do log base 20 of, we're going to type in it so it's negative, make sure you use the negative symbol, and put in parentheses -15 minus 2. Hit enter. Okay, we get a value for that. And then we go, we're going to type it in again. 20 of, and there's no variable to plug in on the right side, so we've shown, here it is, they're the same thing, right? So this is a valid solution to this problem, and this is what you're going to be looking to do on the test. So this is good. Okay, this is what you're trying to do. So you see this problem on the test. Okay. All right. We're going to do 2 more examples and then we'll be done. So we're 10 minutes in, so this shouldn't take too much longer. This is, and in your notes, you're going to title this as such. This is a non-example. Okay, this is one that we can't solve. Obviously, you see I wrote it in my handwriting, but it's log base 2 of negative 2n equals log base 5 of 3n plus 10. So don't try to solve this one. We're not working on this problem in this class. Don't try to solve it. Just write down. I'm going to pause so you can write this down, and then when you're done writing it, I'll explain why we can't solve it. Maybe you've already figured out why it can't be solved by the time you've written it. Okay, so you had time to write it. You'll notice that bases are different. Okay, the bases are different, and so we have a rule for solving these questions that we're gonna remember. So let's put a little star. We're going to say this: we will only solve log equations have same base. Okay, we'll only solve these that if they have the same base. So you're not going to get a test problem like this, but I'm just making sure that it's clear to you for this class. Now, if you take pre-cal, this will be taught a little bit further, but if you run into a question that has different bases, we're not going to be worrying about that in this course. Okay, and you're not going to be assessed on it in this course either. They should have same bases like what we've been seeing. Okay, so there's that. Final example, and then we're going to be done. All right, so I'm going to pause it. You're going to write this in your notes. Natural log 5n minus 6 equals natural log 2n. So I'll pause, try to work it, and see if the answer works. Okay, so you've had time to work it. So the question is, what is the actual base? Here we could plainly see them, but for natural log, what is the base? Well, it's e, or Euler's constant, right? It's log base e. So this doesn't really cause any trouble at all. All we have to do is, and hopefully you did this, is just write 5n minus 6 equals 2n, and just solve it, right? Just solve it like a normal equation like you would. I'm just going to subtract 5n just to get n alone. You could work this any way you want as long as you get n by itself. This goes away. We get negative 6 equals, this is negative 3n, and then we're going to divide by negative 3. Goes away. So n is equal to, that's going to be 2. Then we just need to check it really quick to make sure that there's no non-real parts to this. So let's go with, I'm going to control, that's my inspired, but you guys should know how to do this on the 80 series if that's what you're using. So 5 times 2 minus 6. So I get that, and then we have natural log, let's do it again, on the right side. So that's 2 times 2, and it works, okay? So these are the 3 examples that I wanted to work with you. Your test is going to be, by the way that this date is looking, it's the 20th right now. Your test is the 21st, so make sure that you remember this for that. And if you have any questions, let me know.